In this video, we'll continue our discussions of planes and 3-space. So find the plane with a point containing that whole line. Okay, so first thing I like to write is what I need. I need a point. Okay, I have that. And then I need a normal vector to the plane. All right, so we have the point. Let's start thinking about how we can get a normal vector. I know that I can grab a directional vector from the line. So that directional vector, which is like our slope, is 3, 1, 1. Right, so there's my directional vector. Now, that vector, though, is not a normal vector to the plane. The line is in the plane. That directional vector is the direction of the plane. Because the line has to stay in that plane. So to be able to find an orthogonal vector, though, I'm like, okay, I have a vector in the plane. It'd be nice to have another vector in the plane. Well, I have this point. If I have 2 points in the plane, I can create a vector. So this is a point. I can create a P here, a P1, by the numbers that they gave me in the numerator. So I got a 1. We got to be careful here. Notice that's backwards. That means that it's y minus 4 over negative 1. Think about distributing that negative 1 up top. So be very careful with that. I got 4 and I got 2. It's very easy to miss. I almost overlooked it. Okay, so I do have a point, and then we're going to create a normal vector by taking, first let's create a vector from the points I have. So P to P1 vector. The reason I'm doing this is it's going to give me another vector that's in the plane, and then I can cross my 2 vectors that are in the plane to give me an orthogonal vector. So P1 minus P, so I got 1 minus negative 2 is 3. I got 4 minus 1/2 is going to be 3, 8, and 1/2, which is 7 over 2. And then the last one is going to be 2 minus 2, which is a nice pretty 0. So what we're going to do now is we need that normal vector. So my normal vector is going to be a cross of V1 crossed with PP1. I got I, J, K. I put my vectors in there. All right, and then we begin our cross. All right, so I cover up I and I write down what's there. Then I do minus, cover up J, write what's there. And then I cover up K and I write what's there. I know I'm going a little quick, but I want to keep the videos short. All right, so there's my cross product there. I follow my determinant now. I got 0 minus 7/2 I minus negative 3, or 0. Let's write down each one. 0 minus 3, J, plus, that's going to be 21 over 2 plus 3, K. It's not pretty, but it's okay. So my normal is negative 7/2, positive 3, and then what is that going to be? That's a 6 over 2, 27 over 2. All right, so that is my normal. I'm also going to use the first point that they gave us. So let me scroll back up. I got negative 2, 1/2, 2. And now I can write the equation of my line. I have a point and a normal. So we have negative 7 over 2, x plus 2, plus 3 times y minus 1/2. And then the last one, 27 over 2 times z minus 2 equals 0. It's okay that they're not pretty. Most numbers in the real world will not be pretty. They'll be worse than this. All right, so the deal with the plane, what I'm always looking for is, they usually always give me a point. It's the normal vector that I have to come up with. So if they gave me a line, I know that the line usually goes with it, and I'm going to have to probably do some kind of cross product. So we're looking for that consistently. Cross products. Is there a cross product happening? Can I use a cross product to get an orthogonal vector to describe the normal? All right, we have another example in this one. Find the plane containing, okay, we have 2 points, and it's orthogonal to P1. Okay, so I'm going to name this plane P2. Let me stay color-coded here. P2. I drew a picture to help because it definitely helps to understand this picture. Okay, so I have P and I have a Q. So what do I need to create a plane? The need is a point and a normal vector. All right, we're looking for P2. Okay, I labeled this P2 wrong earlier when I made this. This is P1. Okay, cool. All right, so from P1, we can find a normal vector given from the equation. Remember, they are their coefficients. That's in general form. So I got -1, 1, -4, right? This vector is a normal vector to my P1 plane. So what that means is it gives me a vector that goes out this way that is orthogonal to that plane. Here, let me get my little box in there to look good. Too much time on it. There we go. Okay. You get the point. I don't think that even looks better. So I'm going to stop because I will obsess. All right, so I know that's a right angle going that way. This is N1. All right, so I have N1 like that. I am looking for a orthogonal vector going this way, right? This is what I need. Now, right away, I see two vectors that live in a plane. We didn't make a vector yet, but we have point P and point Q that live in my orange plane there. You can see it there. Well, we did a point P and a point Q. We can create a vector from those points. So let's go ahead and do that. We'll call it V1. V1, let's do this in orange to stay color-coded to each plane. Okay, V1. All right, let's call this V2 actually. V2 in plane 2. That's why I did that. 3 minus -2 is 5. Actually, let's label this what it is for your note's sake. This came from PQ. 3 minus -2 is 5. 0 minus 1 is -1. -5 minus 0 is -5. I also have N1, which is, we have it right above. I don't need to rewrite it. All right, so to find the normal for plane 2, it's going to be the cross product of the normal from plane 1 with PQ. Notice that if I take N1, look at our picture, N1 and PQ, and I cross those, I get that pink vector, right? That orthogonal vector that I'm looking for. All right, so let's do so. All right, I, J, K. All right, I got -1, 1, -4. I got 5, -1, -5. All right, cover up your I column. You got 1, -1, -4, -5, I. Minus, cover up the J column. Get those, J. And then the last one, let me scoot this over so I'm not at the edge of my iPad. My hats didn't move. There we go. All right, plus, cover up the K column. I got -1, 5, 1, -1, K. All right, I got -5 minus 4, I, minus 5 plus 20, J, plus 1 minus 5, K. So this vector is -9, -25, -4. Okay, that is my normal for the plane. I also have a point. The point was -2, 1, 0. And then with the equation of the plane, I have what I need. -9 times x plus 2 minus 25 times y minus 1. And then -4 times z. And we don't need to put z minus 0. You can. It's still right. It's not wrong. That is the equation of the plane that contains those 2 points and is orthogonal to the plane in question. Drawing a picture made this problem for me so much easier to understand what I needed to do. It showed me that if I drew that and I drew the vector PQ and I drew the vector N1, the normal vector, you can see that they live in the same plane. and we can just cross them to get that pink vector, the orthogonal vector there at the end.